Okay, welcome to this lecture. I would like to start this lecture now. Time is up 10:35. Today we are going to discuss the problem of computing the missing values of function. Are you getting my voice?
Yes, sir.
Yes, sir.
Audible? Okay. So I had some problem in sharing the screen. I was sitting for long back before 10:30, but I was unable to connect it. So anyway, uh, we start the very important topic as we have discussed yesterday on the previous turn, that how the differences of the polynomials can contribute to the computing of missing values of the function. So I think this is one of the fantastic application of the differences of the polynomial, and now that property we are going to have exploited for this application. So let us look here, this one. Computing the missing values, we are considering here the y is equal to fx function, and for this corresponding data set is xi, yi. We have started from, look at here, this point is to be taken mindfully, because I have taken from I is equal ranging from 1 to so forth so on up to n. Okay, I have not taken here 0. You can take here 0, no problem. If you want, you can take here 0. I have no problem. But I have just shifted from the traditional system so that you can have some different experience about this. Now, suppose this is the value of the y, this is value of the y, this is value of the y corresponding to values of the arguments. So we get y1 corresponding to value of x1, we get y2 corresponding the values of value of x, that is x2, we get y3 corresponding to the value of x3, so forth so on. We get yn corresponding to the value of xn. So suppose we have the y1, we started from y1 and then y2, so forth so on. We are going to have the value, suppose y3, suppose y3 is here, and then y4 is missing here, and then we are given the y5, and then we are given here this y6, and so forth so on up to yn. Suppose these values are given, but one value is missing. This value is missing. Here this value is missing. Means y4 is not given here. Similarly, not only one value, suppose y6 is also not given here. So we are given only, if suppose one value is not given, then how many values are given? N, means n minus 1 values of the function is given. Suppose here y7 is also not given, here is also missing, then how many values are given? We are given y n minus 2 values. So 2 values are missing. So how to find out these 2 values or 1 value? So one or more is here. Some values mean one or more values may be missing in the given or tabulated values of the function. Then what is the method, what is the procedure which can give us the missing values? So now the method which we are going to describe today is this method. What is this method? What is this method? Now, this, if you look at here, no, this, what is it? Okay, okay, I just take the eraser of this. Right. Now, this method I would like to explain. According to the, you look at here, according to the given function, how many values are given in the tabulated set or data set? There are n values. N values of y corresponding to n values of x. This data set is given. So polynomial, if data set is having n plus 1, if data set is having, if you remember, if data set is having the n plus 1, what values? You remember your previous knowledge. So n plus 1, then what was the degree? Degree was n. In previous lecture, means yesterday's lecture, this was degree. Degree of the polynomial. But here how many values are given? We have not included 0. Remember this point. So therefore polynomial has the degree n minus 1. How many data set you are having? Less than 1 is the degree of the polynomial. Yesterday we have seen it. Degree of the polynomial is n, but data set was n plus 1 in yesterday's lecture. Do you get me? This point is clear? Hello?
Yes, sir.
Okay. So this point is clear? The data set, number of data set is n plus 1, then degree of the polynomial is n. Yesterday we have seen it. Today the data, number of data is n, and therefore the degree of polynomial is n minus 1. Is it clear or not? Okay, so if it is clear, then we come to the next point. Come to the next point. That point is, then according to the fundamental property of differences of the polynomial. Look at, this was the yesterday's discussion, previous discussion. Therefore it is under the inverted comma. Difference, that is the nth difference here, is equal to 0, because the n minus 1th difference is a constant. Is a constant. Is it clear? The degree of the polynomial, the maximum difference of the polynomial is the degree. That is, it is immediately comes constant value, and more than the degree of the polynomial is 0, because there is no any argument to add the increment. This was the main logic. Okay, so delta n is y is equal to 0, and if you replace the shift operator, if you remember, this is the shift operator. I have applied here the shift operator delta. The forward difference operator is equal to e minus 1 to the power n, y is equal to 0. You expand this point. You expand it. E to the power n minus n e to the power n minus plus n minus 1 into upon factorial 2 e to the power n minus so forth so on. The last it e to the power minus 1 to the power n. Y is equal to 0. This is the expansion. Okay, this is NC0. Remember or not? This is binomial expansion. This is binomial expansion. NC0 here factorial NC1. Though you are getting n here n minus 1 upon factorial e to the power n minus 2 so forth so on, and lastly you are going to have the minus 1 to the power n. This term will remain only here, the last one, and y is equal to 0. This is A. If this relation is used to compute the missing values, which the relation A is very important here. So this relation we are going to use, this method is established by the Newton, and therefore what is this? This is known as Newton's binomial expansion method. This is a Newton's developed by the Newton, but it has been the binomial expansion has been used in this method, and therefore the name of the method is known as Newton's binomial expansion method. And this formula is what? This formula is called, we can write here, this formula is called, here I'm going to write here, this formula is called, this formula is known as Newton's binomial expansion formula. So this point is, I think, okay, Newton's binomial expansion formula. And please mute your mic. Somebody has opened his mic. Please mute it. Okay, this method is known Newton's binomial expansion method, and this formula is known as Newton's binomial expansion formula. Okay, let us go for the example. Is it clear?
Yes, sir.
Okay. Okay, now we go for next one. The example. Look at the example. Example is please mute. Okay, so in this example you are seeing here, they determine the missing values in the following tabulated data, tabulated values. So here value is given, this is x argument, this is y, the value of the function, 1 corresponding to 1, x1, then this is y1, this is, if you want to say it y0, I have no problem. If you want to say this is x0, I have no problem, you are going, but 1, it is from serial, so this is nothing else but this is x1. I have shifted you from the traditional way of writing from x0 so that you can have some confusion and you can strengthen yourself in better way. So this is x3 and this is x4 and this is x4. This is x5. Similarly, this is y1 and y2. This is y3. And look at here. Look at here. Y4 and this is y5 corresponding to value of x4. This value is missing. So we have the purpose of this numerical demonstration is to find out, to compute. Suppose this has number of values of arguments. Not only this table is very high, it is starting from 1 to 100 values. Suppose. Then 1, 2, 3, 4, 5, 6, 7 up to 100, 1000. Can you do it manually? You cannot do it manually. If there are 10 missing values, can you find out 10 missing values? You will look at in finding out one missing values, how much computation we are going to have. And if values are missing values are high as well as tabulated values are high, then only then we need to program it. We need to use our certain computing language, scientific language, or some software. Then and only then we can compute this one. So in this way, therefore, we always compute here manually. We only understand the problem, but application problems are always supposed to large problems that involves the metadata. Metadata means very large data. So these techniques are used in metadata analysis. And if something is missing, we can find out according to trend of the function. As a mathematician, you are looking at the trend of this function. 1, 1, 2, 4, 3, 9, 4 missing. You can immediately, by your intuition and experience, you can fill up this value. But no, we are going to apply the method by 5 and 25. The function is what? Without applying any formula, any numerical technique, any method, you can construct your function. You can find out your function. This is y is equal to fx, and this is nothing else but the what? The x square. Do you get me? But no, we are going to apply the method. We have given this function deliberately, knowingly why I have designed and constructed this numerical for you, because you can manually verify your result. Once you manually verify, you will be satisfied and satiated better than my lecture. So, okay, you come to the next point, solution. Okay, so we are beginning from what? We are beginning from y1 is equal to this one. We are beginning here. Remember again, don't get confused that I am going to start from y0. Okay, because in the most of the books you will find y0. So given values of y is 4. How many values are given here? 4. This is 1, this is 2, this is 3, this is 4. 1 is missing. So if values are 4, then we are to begin with to start the values of 4. 1 is not given, so we would not count this not given or missed data or missed value of the function. So for, I think you agree with me. This implies that degree of the polynomial is what? Degree of the polynomial is 3. This is the crux of the issue, crux of the method. This is heart and soul of the method. If you are able to formulate this idea, definitely your answer will come out true. If you forget to develop this idea, definitely you are going to make blunder, and then the answer is remote from your calculation. So I think this point is clear. So if this point is clear, then remember the previous property of the differences of polynomials. This gives us to write as, you look at here, third polynomial, degree is the third, so it is constant. If it is constant, we are interested more, 4, 5, 6, whatever you say, then it is nothing else but the given. This is the core of the solution, core of the solution process. This result is the core we have seen. Okay, so here, so what is happening? The degree, the fourth one is 0. So now we shift operator. This is E is the shift operator. We have put here E minus 1 to the power 4, y is equal to 4. This is shift operator. Is it clear? If this is a shift operator, then e to the power 4 minus y, you look at, and you apply this formula. So e to the power 4, this is 1, here is 1, and then you have what? N. If you remember n in the formula, n is here 4, so 4 is here and minus is here. And the next term is how this 6 has come. This 6, how this 6, this is plus, I think no doubt, how this 6 has come. This 6 has come, and what was the formula if you remember? The n minus 1, agreed. This is the n minus 1, and then here was factorial. Here was factorial 2. Agreed. So n is what? This is 4. N minus 1. This is 3. And then this is factorial 2. 2 into 1, that is 2. So 2 goes 2 times here. So this is 6. So this is 6 is here. I think you are agreed. How this is minus 4? This is minus. I make it minus, a very big minus, because already it was made plus. Minus 4, how this 4 is coming? Do you remember the formula? For this, the formula is n and n minus 1 and then x is the n minus 2, and this in bracket, and factorial. Who will tell here? Factorial 3. The factorial 3. These things are not, they are now finished. So this factorial 3, so this is what? This is 4, this is 3, this is 2. And you multiply. This is how much? This is 24. And this much is what? Factorial 3. This is equal to 3 into 2. So this is 6, and the 6 divides 24, and therefore you get minus 4 here. You get minus 4 here. So this is correct, this is correct, and this is correct, and here 1 is correct. And the last is what? This is 1. Last term will be 1 because this has the power minus 1 to the power 4 in the what? In the formula is what? Minus 1 to the power n. Minus 1 to the power n. It was in the formula, so here is the 4, and this is equal to now 1. So this 1 is nothing else but this one. This. So now y is equal to 0. Then here you look at it is operating on the y because these are the operators. For this, the value of this will operate on the y means on the function. Definitely the value of the function. This will operate on the value of the function y. Then y, and then it is, there is no operator here. See. Agreed. So y is what here? We are interested in the beginning value of y. You remember I put here y1. I put here y1, from where I have taken this y1. You look at, I had made emphasis on this very point. This is y1. So we are beginning from y1. Suppose you are here. Suppose you are one more column here. This is 0. I mean, this is 0. Sorry, this is 0. Then this was 0. This is 0. Then this was 0. So here we are going to start the y naught. So in this formula, if it was beginning y naught, you remember here, then it was y naught. I think you are getting my point. Is it okay? Is it okay? Is it clear?
Yes, sir.
Okay. Then for E, now again y1, we have done nothing else, but we have simply replaced the y by the y1. The beginning values of the function, beginning value of the function. This is the beginning value of the function. This is the beginning value of the function. If it was y naught, then it was replaced by the y naught. And ultimately, this is equal to 0. So if you shift operator, you remember the concept of this shift operator was what? The shift operator was E, if it is a shift operator, and if this shift operator, while discussing the shift operator, there was no y1, rather we had y naught. We had y naught. We had y naught. So if it is y naught, the shift operator was making it what? X naught. I mean the shift operator. This was x naught. X naught plus h. This is x naught plus. This is the first one. So x naught plus h, one value you have got. So the first shift operator x naught plus h is what? If you work on the y naught, x naught plus h, this is what? You remember or not? You have forgotten. This is
X1.
y1. Is it clear? And if you make it shift operator, if you take shift operator in this way, shift operator on y naught, shift operator on y naught, then y naught, this y naught is what? This will be what? Y2. Is it clear or not? Because this will be y1 plus equal space. We are talking about the equal space. So y1 plus h, y1 plus h is the y2. I mean, how many times the shift operator? The first shift operator, second time shift operator, third time. So first time shift operator, you reached y1. Second time operator, you reached y2. Third time operator, y3. Fourth time operator, y4. So how many times you are getting the same, value of the function. The first one time the y1, but remember we started from y naught. We started from y naught, but here is not the case. You remember, here is not the case. If you add 0, you start from 0, you get 1. Okay, in the second you start from 0, then you get 2, y2. And therefore, if it is y1, then what you will get? Y5. Is it clear or not? This is most important. I shifted you from the traditional operation of the shift operator and other operators, because in all the books, it is given from y naught. And suppose in the numerical you are not started from y naught, then many of you commit the blunders. They will start, this will make y4, because they do not remember that I have changed this one. They will make y4, they will make y3, they will make y2, this will make y1, and then it is where you will put it. They will say y0 and y0 I have not given in the table. You will start solving, doing whatever you will do. You may be knowing better, but this similarly the 4 y4, the 6 y3, 4 y2, and this is plus. Okay, this is plus y1 plus y1 is equal to 0. I think you got this point. Y5 is how much? 25. Y4 is how much? Y4. It is missing value. Remember, this is missing value. This we have to compute. Missing value. This is missing. This is missing value. And this 6 into 9. Y3 is what? 9. Y4 is what? 4. And then y1 is what? y1 is 1. This is from table I have written. So you simply solve is 25. This is still to get value 54 minus 16 plus 1, and then ultimately you look at here minus y4 plus 64 is equal to 0, and this is minus y4 is divided, y4 divided is 16. By your common sense or common wisdom, you can also apply this was 16. I told you that the function was the y is equal to x square, and therefore missing value was 16. But by applying this method, we have also computed the value of y4 is equal to 16. So how we can nicely compute the value of missing values of the function? And if you are given, suppose you are given two missing values, then how you will solve it? Anyone? If you are given two, how you will solve it? Then you will form the equations, two simultaneous equations. Suppose you are y2 is also missing. Two simultaneous, simultaneous equations. Here will be a simultaneous equation. Then two simultaneous, I am taking them of this. So two missing values are, if two missing values of, if two values are missing, suppose y2 is also missing, y2 is okay, is also missing, okay, then you will have simultaneous equations in y2 and y4. You will get two equations involving y2 and y4, and these two equations will be immediately solved. Okay, solving this, we can compute two missing value. Okay, two missing value of two missing values of the function. Okay, so I think the concept is going to be clear, is now clear, and